We'll now continue section 6.2 and discuss several applications of the trigonometric functions that we've been studying in this section. We have noted that an angle can be measured in terms of degrees or radians. We want to begin by looking very specifically at an angle that is measured in degrees. There are some cases where we need to be more precise than simply giving a degree measurement for an angle. In those cases, we could give the measurement of the angle in terms of what is called degree, minute, and second notation. Now, on the screen, we have the definition mathematically of 1 minute and also the definition mathematically of 1 second. In more clear terms, what we want to remember is that 1 degree contains 60 minutes. And in each of those minutes, there are 60 seconds. Now, when we have a problem that gives us a degree measurement in degrees, minutes, and seconds, we often will want to convert that to a decimal notation for that degree. And we'll look at that in the next section, in the next screen. Now, keep in mind that although these are the definitions, our process for converting between degrees, minutes, and second and decimal notation is going to be to use our calculator. So let's begin with an example. It says, before cutting down a dead tree in your yard, you very sensibly decide to determine its height. Backing up 40 feet from the tree, which rises straight up from the level ground, you note that the angle between the ground and the top of the tree is 61 degrees, 51 minutes, and 39 seconds. How tall is the tree? Okay, so let's be sure that we understand what has happened. We have this tree. We have backed up 40 feet, and we've now looked at the top of the tree. And so this angle of elevation, which is the difference between straight ahead and looking up at an object, is 61 degrees, 51 minutes, and 39 seconds. And we want to use a trig function to estimate the height of the tree. So the first thing that I need to do is I need to take the angle measurement, the 61 degrees, 55 minutes, and 39 seconds, and convert it to an angle in decimal notation so that I can use it in my trig function. So again, we're going to do that by using our calculator. So I'm going to bring our calculator over and let's look at how we plug this in. We'll turn our calculator on. And we're going to enter this in. So I'm going to go ahead and type in my 61. And then I need to get the degree measurement symbol. So that symbol will be found, we see the word angle here above the apps key. So we'll use the second and the apps key to take us into an angle menu. And we see option 1 is the degree measurement symbol. So we're going to press a 1 there. Then we'll enter in the 55. We'll go back to that same menu, so second and apps, and now we're going to choose option 2. And then we'll enter in the 39. Now for the quotation mark, we're going to use, the quotation mark is found above the plus sign in green on my calculator, so I'm going to need the alpha key and the plus sign. and pressing enter is going to give me a decimal approximation for that angle. So when I work the problem, I'm going to use 61.9275 for my angle. Okay, so let's go ahead and set this up. So notice that we're looking for the height of the tree. So I am going to call this X. This is what we're trying to find. And notice that we also have the bottom side of the triangle. So in relation to this angle, we have the opposite side and we have the adjacent side. So which of your trig functions uses opposite and adjacent? Good, so we'll use the tangent function. So I'm going to say that the tangent of my angle, and remember we're going to use the angle that we got off the calculator, and we're going to set that equal to the opposite, which we're going to call x, divided by the adjacent, which we'll call 40. All right, now we need to solve for x. So we will multiply both sides of the expression by 40, which is going to cause my 40s to cancel over here, leaving me just x. And then I have 40 times the tangent of my angle. And we can enter that into our calculator. So let's do that. We're going to do 40 times tangent, and we're going to enter in our angle 61.9275 and close the parenthesis. Now before I press enter, remember that we need to check our mode to be sure that we are in degrees, because that 61.9275 is a degree measurement. So I'm going to press my mode key. I note that I am not in degrees, so I'm going to make that change. And then I'll press the clear key to go back and then press enter. And so we can see that rounding, it's going to round to 75. And so the tree is approximately 75 feet tall. Okay, so let's move on to another example. The manufacturer of a certain brand of 16-foot ladder recommends that, when in use, the angle between the ground and the ladder equals 75 degrees. What distance should the foot of the ladder be from the base of the wall it is leaning against? Okay, so let's get a picture of what this looks like. All right, so again, we have a 16-foot ladder. You can see that in the picture, and it's labeled 16 foot. We see that the angle between the ground and the ladder is 75 degrees. And we want to know what distance should the foot of the ladder be from the base of the wall. So we're looking for this bottom side from the wall to the base of the ladder. All right, so let's pull that triangle out just for a second so we're sure that we're clear on what we're looking for. So it's a right triangle here. We know that this angle is 75 degrees and the hypotenuse is 16. And we're looking for this bottom side. So if you look at that, we have, in relation to the 75-degree angle, we have the adjacent side that we're looking for and the hypotenuse. So which trig function does adjacent and hypotenuse? That would be our cosine. So we're going to say cosine of 75 degrees is equal to the adjacent side over the hypotenuse. Now again, we want to solve for x. So we're going to multiply both sides of the expression by 16, which causes it to cancel here. and we'll enter 16 times cosine of 75 degrees in our calculator to get our answer. And when you do that, 16 times cosine of 75 degrees, you get 4.14 feet. So that ladder should be moved out from the wall 4.14 feet. Okay, so let's look at one more example. This is an example of a surveying problem. In many of the surveying problems that we'll see, it is often necessary to determine the height of an object when you cannot measure how far away from the object you are. All right, and that is the case here. So let's look at this. Approach from one direction, Mount Baldy rises out of a perfectly level desert plain. A surveyor standing in the desert some distance from the mountain measures the angle of elevation between the desert floor and the top of the mountain to be 60 degrees, 1 minute, 6 seconds. Okay, so look for a second at the pink or the red triangle. The problem is that it is impossible for us to know this distance that we're standing back from the middle of the mountain. We could measure the distance from the edge of the mountain to where we're standing, but measuring from the middle of the mountain to where we're standing is impossible. So that is our problem. All right, and then it says that the surveyor backs up 1,000 feet. So we back up another 1,000 feet and we take another angle of elevation to the top, and we find that to be 56 degrees, 3 minutes, and 23 seconds. The question asks us, how high above the desert plain does the mountain rise? Now, we have a formula that's fairly well known to surveyors that will help us in determining this. And in the book, it goes through how that formula is derived. I'm not going to do that here. So I am simply going to give you the formula that you will be using in this type of situation. All right, so our formula is going to be D, and we'll talk about what things mean in just a second, divided by cotangent beta minus cotangent alpha. So this formula is used for our survey problems when it's impossible to determine the distance that we are from the center of the object that we're looking at, okay, as we saw in this mountain example. All right, so let's consider what the letters stand for. D is the distance between the two sidings. So if I go back, we see that the first siding was made here. The second siding was made here. The distance in between is 1,000 feet. So the 1,000 goes in for the D in my formula. Now, the beta and the angle and the alpha are the two angles. All right, so the alpha is going to be the first angle. In our case, that is going to be the 60 degrees, 1 minute, and 6 seconds. And the beta will be the second siding that was taken, or the second angle. So our second angle is the 56 degrees, 3 minutes, and 23 seconds. Now, keep in mind that we need to convert both of these angles, which are currently in degree, minute, and second form, into decimal notation before we can use it in the formula. All right, so let's do that. So I'm going to start with the 56. Let me pull up our calculator. All right, and remember how we'll put it in. We're going to put in the 56. We're going to go to our angle menu, which is second and apps, and choose option 1. Then we'll do 3 and go back to our angle menu, second and apps, and choose option 2. And then we'll do 23 and we'll use our alpha key and the quotation marks above the plus sign, and then press enter. So our first angle will be 56.0564, rounding to 4 decimal places. Let's go ahead and do the second one. We'll do the second one in the same way. And so the second one will be 60.0183. Okay, so adding those into our formula, we had the beta was 56.0564 and the alpha was 60.0183. And we're going to enter this into our calculator. When you enter it in, let's kind of do a couple of things separately, especially since we're dealing with the cotangents. All right, so I'm going to go back to my calculator just for a second. And let's do cotangent. So remember that that's going to need to be entered as 1 divided by a tangent. 56.0564, and that's going to give us 0.6731, rounding to 4 decimal places. And let's go ahead and do the other one as well. 1 divided by tangent 60.0183. And that gives us 0.5769. And so we'll plug those into our formula. And enter the remaining calculation into our calculator. You probably do need to put the denominator of this in a set of parentheses if you're entering it in all at once. And you should come up with 10,395 feet for the height of the mountain.